This is Serge from the IDB. I have a quick question in terms of quality of data, because as we know, most of our projects are in countries that the quality of data is pretty low. So in terms of taking into account climate change and all those models in those countries, and specifically on a project basis, which is really small most of the time, how would you use all those different tools specific for a project, let's say in Venezuela, in a small part where the data is scarce? How would you sort of work with that?
Yeah, I'll address this first, and then if others, Fernando, want to talk also, that'd be good. I would say, for one, that the information we have on climate change right now, it generally comes from general circulation models that are run at very coarse scales. So no matter what we do in terms of downscaling, in general, I'll say, you're going to be stuck with the data being run at that coarse resolution. So I think it's important, for one, to look at regional patterns of change and try to apply that to your local system, where it might be occurring. You can improve the knowledge of the local climate from those general circulation models through some statistical downscaling techniques. But the problem is that you need to know what the historic climate was like at that location, and often you don't know in a lot of the places that you work. There's also dynamical downscaling or regional climate models that can be run. They're a lot more computationally intensive to run. And I think that the jury's still out as far as how much better you get. A lot's unknown about how more regional and local climate processes work, and as CO2 and other greenhouse gases increases, how is that going to play out on that local scale? I mean, they have a hard enough time modeling it at the very coarse global scale. So I think my answer to you would be that, you know, we're stuck with the data we have. So for one, we're going to have to work with that. We can look at regional patterns and try to apply that to our local scale, and we can do some downscaling and use that as best that we can.
Any of the panelists had a comment or adding on to what Evan has indicated?
I don't have any experience with the kind of models that these other panelists are talking about, which are really just fascinating models to me, and how it's the analysis. What my comment would be that if you can move, there's no reason not to be moving ahead on the projects, and if nothing else, you're beginning to gather data from that point. One of the panelists here or earlier session talked about if we get stuck looking for the data from the past, you know, it's no longer going to be, it's not relevant to what we're experiencing now with this change. So I don't know, in the case of, you know, the city where I am, we're moving forward on projects because we know we're going to make a change. Cumulatively over time, that will add up, and if we wait until we have all the data, you know, we're going to be waiting way too long. One of the things I was talking to others about earlier, and I don't know if it pertains in developing countries or not, but something we're expecting to see a lot of benefit from a data point of view, at least here in the U.S., is crowdsourcing of information. So it's the person with their cell phone with a GPS location beginning to gather that information. How you validate that data in a developing country or even in the U.S., I'm not sure, but some of it I think is a way, that's one way we need to be looking at in the future, that we're going to be getting to get real-time data, which whether that supports a modeling process, I don't know. That'd be a curious endeavor to look into whether it does, but that's another aspect we need to be looking at as we move into the future.
Sorry, I'll just add two things that I think are really important to look at. And the question I always ask people when they say there is no data for this special place that I'm working on is, what do you need the data for? If you're working on a vulnerability reduction project, you're interested in adaptive capacity and the historical variability and our inability to meet our needs, or our inability of our adaptive capacity to deal with current climate shocks. So in many of those cases, we don't need to go to the climate models for information. In addition to that, there are other ways of exploring forecasts. For example, if you're looking to develop an early warning system that really tries to alert people, institutions of potential risks from flooding or fires, you can build those early warning systems by actually downscaling forecasts rather than using forecasts from very cheaply installed weather stations rather than using global circulation models. So the form fits the function, and GCMs are not the solution for many of the challenges that we face. And we just have to be aware and honest as scientists and be able to say that where we are today is not going to give you any better information to make a better decision. So.
Here, and one on the back. So let's begin here with Larry.
Hi, this is Larry Jiang from IFC. And this question is for Dr. Baer. You mentioned very interesting that the project sponsor willing sometimes you say that pay additional cost for design with some flexibility to adopt climate change in the future. But because time-consuming constriction, you didn't give one or two examples. How much higher the additional cost can be? And is client, your client, sponsor, project sponsor, agree to pay for that, for the some of the impact will happen in 20, maybe 30 years later?
Is this working? Yeah. It'll clearly depend on the project and what the adaptation, what flexibility you're buying. Some is just, I've seen, some could be quite cheap. It's just a matter of, I'm trying to think of a simple example. Let's take a building. In fact, I think the World Bank building was built at one point for expansion later on. I don't know if that's true, or maybe I'm thinking of another building in Washington. But you pay a little bit more, or maybe 5%, 10%, it could be a lot more, for being able to to modify the interior or to add floors or things like that. It really depends on what you're buying. Some things are fairly cheap, some are more expensive. But in the end, you made this comment about later on. You may reap the benefits of it, in which case it's well worth it, or could be worth it, or you may not because you regret paying that upfront money because climate didn't change the way it might have. And it's a risk. It's a risk management situation is how you want to pay for it. I think the key point is to look at to have the information about what would happen if you're wrong, and to decide whether or not you're willing to take the risk. One of the problems that was mentioned before when we're talking about the cost is these are upfront costs that they're obviously therefore immediate, whereas the costs of being wrong are further down 20, 30, 50 years. And if we use I didn't go into this, but if we use a traditional economic basis for evaluating that with a discount or an interest rate, then it looks like nothing now. So when we do the traditional economic analysis, then it may not look like it's worth paying for that for some of the flexibility. But all I'll say is somebody who is getting on in age, and as my generation, and is now paying for some bad decisions that were made 40 years ago, 50 years ago, and what I don't want is my children to pay for the mistakes that we're making or might make now. That was an editorial comment.
Thank you.
Hi, Shi Liang Tu from Asian Development Bank. Questions for, two of you. One is, the question is, we are sometimes dealing with not just one project location, but a whole river basin or a whole water resources management system. Does your tool, no matter the World Bank portal or the InVEST, the Wizard, deal with a river basin which the upstream might experience irregular glacier melt, but midstream may be having drought, but downstream having the flood, or multidimensional issues which relates to climate change?
Let me just begin by saying that our team and Evan's team has been working, or has plans to work together to try and integrate some of these tools into a single source for decision makers. So that I just wanted to put that out there. Your question, I think, is really dependent on the size of the basin, of course, right? Because we're relying on these global circulation models with an average resolution of 300 kilometers, let's say, or I guess that's the maximum, 300 by 300. It just depends on the size of the database. And what I will say, though, is that this new water impacts data that is coming online in the portal was developed as a climate change project with the water anchor here at the bank. And that is looking at sub-basin scale resolution changes in runoff and recharge and irrigation deficits. And those will be at the sub-basin scale. I think there's something like 14,000 sub-basins across the world. So.
Yeah, address this in terms of, one, the scale of the data that you can work with there. How fine are you comfortable? How fine, can you get relative to how big your basin is, whether you can pick up those kind of changes. And then secondly, in terms of the different tiers of models that I was talking about, that I showed a tier 1 model. That is what the INVEST toolkit has produced right now. There are some other models out there that are not part of INVEST. For instance, the VIC variable infiltration capacity hydrologic model, SWAT hydrologic model, a lot of other hydrologic models out there that can get down to the sub-basin. I mean, that also can get to the sub-basin, but can get to some of the processes that you talked about, such as differences or the effect of snow melt, the effect of different soil layers, and et cetera. That with more complex models, you can get some of those issues, but it's all then going to be dependent on how fine of scale resolution climate data you can feed into that model.
Great, thank you. I have a question. Anybody else wants to comment on this? We are okay. Oh, I had a question on the back here.
Hello, my name is Sheila Mwanundu, and I work with the International Fund for Agricultural Development. My question is directed to the lady who gave a presentation on the World Bank Knowledge Portal. I'm curious to know whether the information therein relies solely on scientific information, or whether you see indigenous knowledge or traditional know-how as an important input to the portal. Thank you.
Thank you for that point. I think it's something that I forgot to mention. With the development of the portal was really meant to provide robust, peer-reviewed scientific information to support decision-making. However, the portal is linked. It is actually a true portal. In other words, it's a gateway to additional tools that are collecting information and experiences at the field level and project level about adaptation and vulnerability and adaptive capacity and experiences with climate change that are actually linked to the portal. One of the tools that is very important for that is the We Adapt platform, where the collective experience of communities is actually being shared. The other one is the Africa Adapt program and the Climate Change Adaptation in Africa program. And again, all of these are linked within the portal. So while we don't provide that information, you can actually use the portal as a gateway to try and get that.